Welcome to Thermotron's webinar, Electrodynamic and Repetitive Shock Vibration. Which is best for your application? Thank you for registering and attending today's webinar. Feel free to submit questions at any time. After the presentation, we will answer as many questions as time allows. If we miss your question or run out of time, we will provide a document with all the questions and answers. My name is David Kajowski, and I'd like to introduce the presenters for today's webinar. I am the Marketing Manager here at Thermotron. Jane Newton is the Marketing Coordinator and maintains the content and design of the website and product literature. Eric Shaw is the Sales Analyst. He monitors market trends, analyzes market segments, and energizes product line growth. Today's presentation was put together with information from Thermotron electrodynamic and repetitive shock vibration industry experts. This presentation will begin with Thermotron's company profile, followed by an explanation of vibration terms and vibration types, and then a comparison of electrodynamic and repetitive shock vibration testing. We'll go over some common specifications for each vibration type in Thermotron's vibration offerings. We will wrap up today's webinar with questions and answers. Thermotron Industries is headquartered in Holland, Michigan, and is one of the world's largest manufacturers of environmental test chambers, vibration test systems, accelerated stress test equipment, and functional test and measurement equipment. Our core competencies include refrigeration, heat, humidity, vibration, combined environments, control instrumentation, application-specific software, and custom design engineered solution for customer-specific test needs. Thermotron has more than 35 years of experience in the vibration testing industry. We have developed an extensive library of worldwide applications and installations. We are the only manufacturer to make both electrodynamic and repetitive shock vibration shakers and combined environment systems. We provide solutions to many of the world's largest companies, and our test solutions help improve product quality and reliability. First, Jane will go over some essential vibration terms that are a foundation of this webinar in vibration testing.
Thanks, David. Vibration testing is performed for a variety of reasons: to determine if a product can withstand the rigors of its intended use environment, to find failure modes in the R&D phase, to weed out product defects prior to shipment, and to ensure the final design will not break during shipping. Vibration is the repetitive transfer of energy in a system from potential form to kinetic form and back again, or an oscillation about a point. Some practical examples of this would be an airplane flying, a car driving or hitting a pothole, or items in a semi-truck while being transported. Vibration tests are commonly used to improve the reliability of military hardware, avionics, instrumentation, consumer electronics, automotive components, semiconductors, and telecommunication devices. Displacement is the distance that a vibrating mass moves. Peak displacement is the center to the peak, and peak to peak is the distance between the two farthest points of motion. It is measured in inches or millimeters. Velocity is the speed at which the vibrating mass moves, measured in inches per second or meters per second. Acceleration is the rate at which the vibrating mass changes speed. It is measured for g-peak for sign and shock testing, and GRMS, which means the root mean squared acceleration, for random, sign on random, and random on random testing. Frequency is the number of times an oscillation occurs in a period of time, measured in hertz per second or cycles per second. Mass is the amount of matter contained in a body or product, measured in pounds or kilograms. Force is the applied energy causing motion or a change in motion. Force is measured in force pounds or newtons. Power spectral density is the measurement of amplitude and frequency in a random vibration spectrum. Amplitude is measured on the y-axis of g squared per hertz, or meters per second squared per hertz. Frequency is measured on the x-axis in hertz. Transmissibility is the non-dimensional ratio of the response to the input motion. The ratio may relate to accelerations, or to velocities, or to displacements. Resonance is the condition in which the frequency of an external force coincides with the natural frequency of the system. Resonance is measured in hertz or cycles per second. This slide shows the relationship between transmissibility and resonance. This is an example of a sine sweep showing input and product response. Here we see a 1 G-peak sine input and several resonance points on that product response plot. Highly accelerated life testing, also known as HALT, applies increasingly higher levels of stress to force product failures. HALT uses multi-axis vibration and high thermal ramp rates significantly beyond the product's normal use environment to expose product weaknesses quickly. Using high levels of stress causes a significant time compression and exposes the same failures experienced during normal use over a product's lifetime. Highly accelerated stress screening, also known as HASS, is a production quality screen that applies similar but lower stresses to those used in HALT. HASS levels are determined by results found in the HALT process. HASS aims to verify that production units are manufactured as designed and quickly detects component or manufacturing irregularities. This screen is tuned so that it detects weak points while still leaving expected field life in the shipped product. Now Eric will discuss the different types of electrodynamic and repetitive shock vibration.
Thanks, Jane. Here are some common tests that can be performed with electrodynamic vibration: sine, random, classic shock, and SRS shock, resonance search and dwell, random on random, sine on random, and RDAP. Each test is intended to produce a different real-world response. Sine vibration is amplitude and frequency that can be determined at any point in time. This screenshot shows the acceleration G peak at each frequency breakpoint and the slope both numerically and graphically. It shows that with a 425-pound load, this shaker is not limited by force, velocity, or displacement. It shows target and control G, drive voltage, real-time velocity, frequency, and displacement. Random vibration is when amplitudes and frequencies are randomly occurring functions and not repeatable over time. The noise source is shaped to represent the environment in which the article will operate. Random vibration is used to closely approximate real-world application environments. A wide range of frequencies are excited simultaneously at closely controlled energy levels. There are many examples of random vibration profiles which plot power spectral densities in units of G squared per hertz versus frequency. Test specifications with frequency up to and greater than 2000 Hz are considered broadband. Random vibration test specifications with upper frequency less than 500 Hz are referred to as narrowband. Full system force is not achievable for narrowband, and the performance must be derated to protect the equipment. This screenshot shows the G-squared per Hertz at each frequency breakpoint and the slope both numerically and graphically. With a 425-pound load, it shows target and control G levels, drive voltage, maximum frequency, lines of resolution, and bandwidth. Shock conditions such as sudden and severe impacts are encountered by a variety of products as a result of actual use environments such as transportation or mishandling. Specific examples include dropped cell phones, automobile collisions, aircraft landings, and missile launches. Most electrodynamic vibration systems have the capability of performing shock. The armature is given an initial displacement, it's preloaded, and a pulse of energy is delivered by the amplifier, which translates into a particular waveform. Classic shock pulses are determined by shape, amplitude, and duration. Typical types of classic shock include half sine, terminal peak sawtooth, initial peak sawtooth, triangle, and rectangle. This screenshot is a 100G 11 millisecond shock profile performed with an 8,000 force-pound shaker with a 200-pound payload. Shock response spectrum testing is a way to synthesize a complex waveform that can be used on an electrodynamic shaker in a controlled manner with repeatability. This avoids the inconsistencies of shock test machines that limit the shape of the excitation pulse. SRS is a useful tool for estimating the potential damage of a shock pulse. SRS tests are used to qualify equipment installed in the nuclear power plants as well as to simulate seismic, pyrotechnic, gunfire, and aircraft takeoff and landing vibrations. Resonance search and dwell is used during sign testing when energy is output at a single frequency. A sign sweep test is a useful engineering development technique that is performed as a means to locate the resonance of a product. The resonance, or natural frequency, is a point where small input levels cause the product to exhibit a high amplitude response level. Dwelling at the resonance point, it is a common practice to determine if a product can withstand a higher level of stress. Random on random profiles combine narrow bands of random superimposed on a background broadband random spectrum. This vibration signature is typical of tracked vehicles, propeller aircrafts, and turbine engines. Certain applications involving rotating equipment in moving vehicles require a vibration profile that combines fixed or swept sine and random vibration. Sine on random software simulates a vibration environment experienced by helicopters, automobiles, and trains, where the sine component of a rotor or a reciprocating piston engine is placed on top of a broadband random vibration profile indicative of the moving vehicle. RDAP allows actual vibration data to be recorded in the field and replicated on the shaker in the lab. This method of testing provides very accurate feedback regarding how a product will perform under normal operating conditions. Recorded vibration levels can be stepped up to higher levels to accelerate the stress testing process if desired. Repetitive shock vibration typically has two types of tests, low and high frequency. In addition, Thermotron offers an exclusive mode called synchronized shock. For repetitive shock vibration in low-frequency mode, the impactors are optimized to produce a flat spectrum with significant energy below 500 Hz. The graph shows a comparison of Thermotron's extreme table to a conventional repetitive shock table. In the graph, the blue is the frequency response from the extreme table and the green is from the conventional table. There are 2 points to make from this graph. One is that the increased low-frequency energy content represented by the area shaded in orange, and 2, the reduction of peaks and valleys in the response ensures equal energy distribution across the entire frequency range. In the high-frequency mode, impactors are controlled to produce high-frequency energy. The graph shows a frequency response between 0 and 10,000 Hz. Energy builds after 2500 Hz in this mode. The high-frequency mode is intended to find products failures faster. Synchronized shock is a Thermotron exclusive vibration mode that performs multi-axis shock testing by synchronizing the impactors to hit at a controlled frequency and intensity. This mode offers up to 1500 G peaks, giving it the ability to force failures that might not occur in other excitation modes. Now Jane will cover the differences between electrodynamic and repetitive shock vibration.
Thanks, Eric. Electrodynamic vibration excites 3 axes sequentially, one at a time. It's an electromagnetic response, much like a subwoofer in a car stereo system. Repetitive shock excites all 3 axes simultaneously, all at once, using pneumatic impactors, similar to a hammer, to produce its response. Breaking down the electrodynamic vibration system into its simplest form would be comparing it to a large, powerful industrial-strength stereo system. Using a vibration control system, which is like the CD player, a signal is sent through to the amplifier, which is similar to the amplifier used in a home stereo, to the shaker, which is like the speaker, where the armature, which is comparable to the speaker's woofer, moves up and down or back and forth in a magnetic field. An added element to the vibration system is an accelerometer that senses the output of the shaker and sends this signal back to the controller for fine-tuning. The controller in turn sends a drive signal back to the amplifier, which provides accurate closed-loop control and spectral shaping of the test being performed. Pictured is an 8,000 force-pound shaker with a head expander, slip table assembly, and control console. The shaker is currently in the vertical position. It can be rotated 90 degrees to connect to the slip table to test a product in the horizontal axis. A product can be damaged or over-tested if it is larger than the size of the armature. A head expander alleviates this problem by increasing the product mounting area. Head expanders are typically made of magnesium because of its lightweight and stiffness properties. A slip table assembly is used when vibration is required in the horizontal axis. The shaker is mounted in a unified base with the slip table assembly, illustrated on the screen. The solid mount trunnion rotator that is connected to the unified base allows the shaker to be rotated 90 degrees, which is aided by a driver bar. Oil is pumped between the slip plate and granite slab so it can smoothly move back and forth, creating surface tension so the slip plate and granite slab don't separate or slap against each other. Isolators help prevent vibration transmission from the shaker to the facility floor. Shown here is an illustration of a repetitive shock vibration table. The air-driven system consists of a table and air hammers attached to the bottom of the table. The air hammers hit many times per second, similar in function to a jackhammer. Depending on the size of the table, there are between 4 and 16 air hammers, all hammering at the same time. The vibration energy produced and transmitted into the product is a result of the hammer strikes and the table resonating. This is similar to the effect of ringing a bell or the sound produced from hitting a drum. This comparison chart is a tool you can use to help determine which vibration test is best for your application. For the performance section, we prioritize the most common performance specification, starting with axes per shaker. Shown here is a required utilities comparison chart for the most common utilities used in vibration: power, water, and compressed air. Shown here is an electrodynamic and repetitive shock vibration graphical comparison. On the left is a graph of a random test from an electrodynamic shaker testing a product on one axis. The yellow lines are the tolerances of the profile, and the red lines are the abort limits. You will notice that the profile output is controlled by the user. The power spectral density output of a repetitive shock shaker is shown in the graph on the right. The three colors represent a product being tested on all three axes simultaneously. The output of repetitive shock vibration tests is random. The goal of electrodynamic vibration is to simulate real-world environments. The goal of real-world simulation testing is to pass the test, ensuring all products, including production units, are up to quality standards and ready for consumer use. Repetitive shock vibration uses high stresses to stimulate product weaknesses or flaws quickly. The goal of repetitive shock vibration is to test the product until it fails. Small electronic subassemblies, as well as more complex mechanical assemblies, are just an example of what can be tested using repetitive shock vibration. If a user is working from a specific specification, it will tell you if you should be using electrodynamic or repetitive shock vibration. Here are some common specifications for electrodynamic and repetitive shock vibration. There are many specifications specific to electrodynamic vibration in order to simulate the real-world environments products will encounter. There are fewer specifications for repetitive shock vibration because they are typically custom-tailored to specific products. Fixtures are adapters that attach to the armature or table to which the product is mounted. A vibration fixture needs to be rigid and lightweight. The vibration fixture should transmit a uniform distribution of energy from the armature to the test item. In many cases, vibration is applied in all three axes. Specialized vibration fixture designs permit the fixture to be rotated for testing in the X, Y, and Z axes. It is common to find the weight of a fixture to be 2 to 3 times heavier than the products being tested. Fixtures should mount easily to the armature or table, and products should easily mount to the fixture. Quick changes from product to product and axis to axis help to maximize equipment utilization and improve lab productivity. Standard fixture kits and custom designs are available from Thermotron. Now I'll pass it back to David to talk about Thermotron's vibration product offerings.
Thanks, Jane. Thermotron's DSX series of electrodynamic vibration shakers range from 2250 to 12,000 force-pounds. All are air-cooled models and have up to 3-inch peak-to-peak displacement. Custom specialized shaker models are available to meet specific performance. For example, a DSX 8000 with 5 inverters can meet the automotive 100G 11 millisecond half-sine shock test with a 200-pound payload. Thermotron's electrodynamic shakers have superior performance. The robust armatures are lightweight and durable, ideal for obtaining maximum acceleration levels. The dynamic centering system is driven by compressed air that consistently and constantly maintains the armature centering. The fully adjustable magnetic field strength optimizes shock performance. It is automatically adjusted by the control system to save energy during operation. To keep up with preventative maintenance and to minimize production downtime, Thermotron field service engineers are factory trained. We have service engineers who are electrodynamic and repetitive shock vibration experts. Repetitive shock table sizes range from 16 by 16 inches with 4 impactors up to 48 by 48 inches with 16 impactors. Standard payload capacities range from 300 to 1,500 pounds. Additional weight capacities are available. Specialized table sizes are also available. For example, the 48-inch by 60-inch table. Thermotron also offers more traditional repetitive shock systems. Our patented dual strike impactors impart stress in both directions, unlike conventional single strike systems. Driving the table in both directions produces significant displacement while stressing the product evenly and using 50% less air than a traditional system. This new technology allows up to 100 GRMS acceleration levels and up to 1500 G peaks in the synchronized shock mode. The patented impactor monitor system monitors impactor wear and prevents large variations in vibration response, helping to ensure test accuracy and consistency. Now I will talk about the patent-pending multi-zone control feature. This is exclusive to the Extreme AST system. This patent-pending feature automatically compensates for test setup variability. Users can test multiple products at the same or different G levels simultaneously. Our advanced control software divides the table into 1, 2, or 4 zones and controls each zone's vibration levels. Thermotron is the only manufacturer of environmental test chambers, electrodynamic shakers, and repetitive shock shakers. Pictured here is an agree chamber with mechanical refrigeration that interfaces with an electrodynamic shaker. This custom chamber can also interface with a repetitive shock shaker, giving a cost-effective solution for multiple testing needs. Thermotron's accelerated stress testing equipment for HALT HASS utilizes extreme temperature change rates using liquid nitrogen in combination with repetitive shock vibration to force failures more quickly than traditional testing methods. The RSL16 portable shaker is an integrated portable shaker that utilizes the universal port on SE series chambers for temperature, humidity, and repetitive shock vibration. This is a cost-effective way to introduce HALT HASS. The shaker was designed to be used in a chamber for full air movement around the product. It can be used in the chamber's full temperature range from -70 degrees C to 180 degrees C. Thermotron software engineers develop all aspects of the controller in-house to be intuitive, secure, and robust. All functions of the test, temperature, humidity, and vibration levels are displayed on one screen. Thermotron controllers have USB and Ethernet connections for quick and easy access to data, making the tasks of data mining and manipulation quick and effective. With the appropriate software, vibration controllers are capable of reproducing the various vibration test types previously mentioned in this presentation. Free controller software updates are available via thermotron.com. For electrodynamic vibration, Thermotron offers the VCS 3200 as a standard controller. We include software packages such as sine, shock, and random tests. Thermotron's repetitive shock vibration controller for the full Extreme AST system is the AST 8800. The power spectral density software package is included with the controller. The 8800 controller is standard on SE series chambers that supports temperature and humidity. When the chamber is equipped with the RSL16 portable shaker, the 8800 includes G levels on the main screen. We understand that your products or tests aren't always standard. So why should your test equipment? Thermotron specializes in custom applications. The 8,000 force-pound shaker on the left has two slip tables. The larger table interfaces with the chamber for combined environment testing. The smaller table is used for the 100G 11 millisecond automotive spec with a 100-pound payload, horizontally. The AST-165 on the right is the tallest chamber ever engineered and manufactured by Thermotron, with a RSL-48 shaker. This was built to accommodate extra tall and heavy products under test. To summarize today's presentation, vibration testing is an essential part of the R&D, production, and real-world simulation phases. Electrodynamic and repetitive shock vibration testing are used by many industries including, but not limited to, electronics, automotive, telecommunications, energy, aerospace, defense, semiconductors, and home appliances. Both types of vibration are meant to produce different responses. From this presentation, we have hopefully given you enough tools to be able to determine which vibration type is best for your application. Thermotron offers electrodynamic and repetitive shock shakers and combined environment systems with state-of-the-art controllers. We specialize in custom applications and solutions for unique testing needs. If you are in the need for a more technical presentation, please contact us or your local sales representative. This concludes our presentation. Now we'll have time for questions and answers. The first question today is for Jane. How is it possible to perform the 100G 11 millisecond half sine shock test with an 8,000 force-pound shaker with a 200-pound payload?
The reason we can meet this specification with such a small shaker is because Thermotron has a rugged and durable armature. Also, we specially wound the armature to meet this specification. We can specially wind armatures for other unique or custom specifications as well.
The second question is also for Jane. What are the benefits of HALT Hass testing?
Some benefits of HALT and HASS are to get results quickly, rapidly identify weak links, learn how to make products more robust, reduce the time it takes to get new products and technology to the market, reduce warranty or recall risks, and efficiently evaluate product cost reductions and redesigns.
What do I need to consider when selecting the size of an ED shaker?
I'll take this one, David. Some things to consider are the weight of the product, cable, fixtures, head expander, armature, and possible a slip table, and the profile you need to run. I would recommend that you contact your local salesperson or application engineer at Thermotron due to all the different variables.
I currently have an SE chamber. Is it easy to add the RSL-16 portable shaker? Eric, can you answer this one too?
I was hoping someone would ask about the RSL-16 portable shaker. Yes, it is very easy to add to your SE chamber. The only thing it requires is a universal port option and the communication cable to be added to your chamber as a field retrofit. It also requires an 8800 controller update to display the G levels, which is downloadable to the Thermotron website.
We have more questions coming in and we'll answer them individually. The complete questions and answers transcript, including answers we did not have time for, will be sent to all of our registered attendees, and will be posted with the webinar when it goes into on-demand mode. We thank you for your time, and please feel free to visit our website or contact Jane, Eric, or me for more information.